Hello and welcome to our next episode in the DirectX tutorial series where we create a DirectX 12 application in C++ from scratch. This is as always, a part of a live stream where I do separate recordings on the different topics that we go through throughout the process. Uh, and Since it's a live stream, primarily featured on YouTube, uh, I will be doing questions, preferably at the end of each video. Um, if you're watching this in the future and you have questions in terms of why something is the way that it is, feel free to leave a comment. I'll do replies as well as I can. Yeah, the GitHub repo gets updated between every video segment that you will find on the actual channel itself. So you can always go back to a previous episode by using the different commit history points or whatever you call them, different commits, earlier commits. I hope that everything is explained in a meaningful way and that the steps so far have made sense. If not, feel free to let me know and I could do a recap episode or a elaboration on different topics. If there are a lot of questions in the comments, I also will maybe do a um, combined episode where I answer your questions. Okay, so during our last episode, we set up our pipeline and our root signature, and during the pre-stream for this episode, I outlined some next steps in terms of what we need to do. We want to bind the root signature and pipeline to the GPU/draw process, and we want to bind a data storage to the input assembler and give it a view/description. Remember, this is our pipeline, so the pipeline takes vertex buffers and sometimes index buffers as input and does rendering on them according to our shader programs, and it sometimes takes other input as um, parts of the root signature. So we need to bind that part of the input assembler stage, and then we need to tell the GPU how to interpret our data. Since we can interpret vertices in different ways. And then we want to do a drawcall. Right now we have no 3D perspective, so I expect the drawcall to be 2D. Okay. Let's see. I'll just make sure that I haven't missed something. Okay, I have actually missed something because we would like the output merger here to have a specific render target as well, so we actually also need to bind that. So let's go through the whole process here. Let's see. We also need to slot that in somewhere. Maybe we actually want to do it before we actually set any GPU pipeline state, because no matter what, we are expecting to use this specific output merger here. So we want to bind the render target to every part of our output merger. You could, of course, render to a texture instead of the render target. Yeah. So we clear our render target here. Let's start by setting our render target. We will do a command list GFX command. For that, we will set the output merger set render targets. And as you can see, we will specify a number of render target descriptors. We also need to give it the address. Well, our address is just above us. We already defined the address / handle of our render target, and we do not pass in a handle to a descriptor range, since there's only one descriptor here, and we do not provide a depth stencil descriptor right now. So we slot that in, and we will do our draw calls here because down here we transition out of the render target state. So we need to do that here. So that's the first step. Check. Then we want to bind the root signature. Let's see. We want to ask our command list here as a graphics command. Bind maybe set root signature. Set graphics root signature. Yeah, we have a call for that. Okay, we need to provide a pointer to the underlying interface of our root signature. Since it's stored on the pipeline state object here, we should create a method where we can get a pointer to the interface, and we will do an inline function here, get root signature, where we return the root signature pointer to the underlying interface. So inside our renderer here, we can do our root signature base pipeline state get root signature address, and we simply bind that. Then we also want to bind our pipeline as mentioned in the outline here. Set, let's see, do we have something? Set pipeline state. Okay, there we go. So our base pipeline, since it's a COM pointer that wraps the underlying interface, we can simply just call get on the class itself, and we will bind our pipeline. All right, things are going smoothly so far. Then we need to bind a view. Let's just swap these, since we could easily get done with this part of the setup. We want to register a command, and IntelliSense already knew what we wanted to do. We want to set the primitive type topology. And let's see, the 3D primitive topology. I think we will do a triangle list if I recall correctly. Let me just be certain. Yeah, we will do a triangle list. So now the pipeline expects vertices to be grouped in 3 and to be the basis of yeah, triangulated faces. All right. Well, last step is to create a, not last step, but the next step is to create a so-called vertex buffer view, since we need to bind that to the input assembler. We have a resource that we want to be a dynamic vertex buffer. So therefore, we can simply create a vertex buffer view for that. Let's see. Let's arrange ourselves so that we do everything related to the buffer in one place. D3D12 vertex buffer view is the data storage for this. Maybe we want our renderer API to store that for us so that we do not need to create it all the time. Dynamic vertex buffer view. And we want to specify the buffer location. It's a virtual address, the size of in bytes, and the stride in bytes, meaning how is the buffer itself actually laid out in memory. So let's fill out the description here. Our buffer location is, of course, our buffer location here is, of course, our GPU virtual address, as you can see here. So we need to fetch that vertex buffer here. And maybe if we get the underlying interface, we could get the GPU virtual address. Okay. Then we want to set the overall stride in bytes, meaning how should the buffer be interpreted in terms of, if you look at the buffer, how are the different elements stored. How many bytes does it span per instance or element? And here we want to tell it that we have a vertex layout, which are our structure here that actually gets stored in our buffer. And then we need to tell it the total size in bytes, so it knows where the buffer ends. And since we created a buffer with 16 kilobytes here, we will simply store that. So it's basically some of the same components here that is used to describe the buffer itself for the pipeline. In my other project, I do it on the actual resource itself, so that the renderer doesn't have to store it, but the object, the resource itself can provide its own description. But yeah, it's fairly simple to implement, and you can do as you see fit. we just need to provide a so-called view/description of the object, and we do that now. Last thing is that we want to bind the actual description here. So we do another graphics commandless call where we set the input assembler, set vertex buffers, um, uh, and we simply bind it. I think we will, let me just look up the actual input slot itself. I think it's 0, yeah. So the first slot here, the number of views that we provide, and a reference to the actual buffer view. Let's see, dynamic buffer view, and the address of that. Now it knows that this is not an array, this is just one single instance of a vertex buffer. All right. That should be it. Let's see if everything compiles and if we can actually do a draw call. Okay, we have some error. Okay, so it complains that we haven't done a specific. Okay, we have a problem creating the pipeline state here. Okay, let's look into that. Okay, if we the vertex shader expects application provided input data. But none is bound. Okay. Let's see. Let's look up this error. Well, we're not getting any help from our search here. Okay, I think this relates to probably our pipeline description. So maybe we're not done in terms of doing the description itself. Oh, wait a minute. Oh, wait a minute. There's an error in the old code, I think. We simply do this description here, but we do not bind it to our pipeline. So we just created the data here, but we need to pass it into our description, which our debugger here kindly tells us. So we need to set an input layout with as our input layout here and copy it over. Let's see, let's set that as a grouping here. And there we go. No errors, no problems. We still need to release some resources. We will handle that later. Yeah, so during our last episode, I forgot that part. Yeah, but since we're not doing any drawing in terms of that, I don't think you'd run into problems. But maybe I should specify a node on last the episode with the pipeline needs input assembler set. Okay, that is a note for my future self to remember. Okay, but other than that, we actually succeeded in binding our information here. But right now we only upload one vertex, and right now we have no way of interpreting our information, since our or rather we do, but our shader programs here get important, because let's see what we do with the actual input. Well, in the vertex shader, we simply pass it along as a SV position, meaning that this is a specification of where the pixel or object is located in screen space. So we simply take our 3D space position and add an extra element, since that's needed for this position here. Yeah, and we pass along the color. So we basically pass the information along, and then for each position, pixel position, the pixel shader just draws the color. The point I'm trying to get to is that since we have no real computation between what is 3D space and 2D space, this position here actually describes a 2D screen space position, because the vertex shader simply passes it along. That means that the actual positions are in screen space coordinates, and let's see, screen space coordinates of DirectX. And as you can see here, the screen space coordinates are as follows in DirectX. So they are mapped on the x axis as -1 to 1, and on the y axis 1 to -1. So let's add that to our layout here. Right now, for screen space coordinates, vertices only have x and y mapped to -1.1 to 1 -1, right? Yeah. So we need to be mindful of that, since we're doing 2D rendering right now. So let's say that we wanted a color here for the first vertex. Let's do 0. Maybe we, to help ourselves do this more easily, we actually want to store them in a vector and pass along the pointer to the underlying data. So let's see, let's do this instead. We create 3 vertices, enough to do a triangle. Like this. we will create a vector that will hold our 3 vertices, since and that will be easier. So maybe we want to give them different colors. Right now, maybe we want to do only red here. And we will do some basic if statements. It's not great code, but we're not really trying to build a um, piece of software that is elegant, since you would need better structure overall to do more elaborate things. Right now, we're just trying to test out our drawcalls here. So if the index is 0, we do something, else if it's 1, we do something, and then lastly, we do something if it's not any of those. Where? Oops. Okay. So we need to remember our coordinates here. Okay, maybe we want to draw the first vertex at our lower left corner. So that would mean that we need the coordinates of -1, -1. So our first vertex here will do -1, -1, and this will just be 0 because we are not using it. Okay, maybe since we're doing, if you can remember, the winding order is clockwise. So therefore, if we draw our next vertex up here, we would need something like 0 dot 1. So the x is 0 and the y is 1. Then we want to do our last vertex down here, which means it will have the position of 1 and -1. And that's it for our vertices. We of course need to add them to our vertex data struct here, or rather a list of vertices. And now we want to do the memory copying of the data. So we do a mem copy to the destination, but we take our vertices data storage and actually get the underlying pointer, and then we need to do a size of our vertex data structure times the size of the vertices here, because we want to copy the whole buffer. All right. Let's see if our upload of the data actually got done correctly. So we will use Insight, since I think that the layout is a bit prettier inside of this debugger here. Okay. If you run into trouble with the debugger, I'll show you why. It's typically because the debugger references the program that is in here, but it suddenly can't find the shaders, because whenever we do the running from the Visual Studio environment, everything gets mapped to this folder here, since it's our opening application and it knows where these files are located. So whenever we just open our program, as we would do, usually you can see that it doesn't know where to find the shaders. So therefore we need to provide the shaders, and now everything runs as expected. So let's try launching our debugger now. Everything looks great. We will capture a frame by pressing F11, and we will look into our buffers here. We have our dynamic vertex buffer, and we know that the layout of it is a series of 3 floats and then a series of 4 floats. Okay, you can see here our vertices got uploaded correctly, which is great. That means that now we can access them on the GPU. Let's try closing some of this. And that means that we should be able to register a drawcall referencing this buffer that is now bound to the pipeline because of the view. It knows where to look, and it, as we saw, we know that there are 3 vertices in that particular buffer. Then we want to do a drawcall. And we do not have an index buffer, so we will simply do an instance draw without indexing. Let's see how many vertices per instance. Well, we specified 3 vertices per instance. We specified an instance count that is, or rather we only have 1. We start at 0 and we start at 0 for both the vertices and the instances in terms of their buffer location. And that's our draw call. Let's see what happens. Okay, nothing happens. Let's see. Maybe we want to change the clear color here. Maybe we're in trouble in terms of actually drawing anything. Well, nothing happens still. We need to debug this. Let's see, we did not get any error codes. Okay. We need to debug this, figure out if we have been missing something. Okay, this is where our debugger tools come in handy, because we can now simply capture the frame and we can look at what's happening. Okay, we have a event list over here where we do an instance draw call. It also gets an object here. Let's see. Whoops. It gets an event here, so we can open the event. We can open the geometry, and we actually do get some kind of geometry that is supposed to be rendered. So maybe the problem is not that we have trouble creating correct draw calls. Everything seems to be all right in that regard. So maybe if we debug the locations here, maybe we're not doing the correct screen spacing coordinates. Well, first we have the -1.1. We have then our second vertex, which we specify. Let's see. -1.1. That's actually up here, right? Yeah, we wanted minus, right? Yeah. So maybe our vertex didn't get specified correctly. Maybe we actually made a mistake right there in terms of figuring out where to draw it on the screen. So let's check the first vertex. DirectX screen space coordinates. Let's see. Let's look up the image again here. So we want, let me just open this window here, or rather the image here. Okay, so actually I wanted to draw the vertex down here, so we need to specify -1, -1. And then up here is the second vertex, so That is correct, since 0 is the midpoint on the x-axis and the y-axis is specified as 1 up here. Then our last vertex is down here, and that should be 1 minus 1. That also explains why our geometry, when we actually inspected the draw call in the debugger, looked weird. Okay, we still do not see anything on the screen. Let's look up our geometry on the actual debugger. I expect that the geometry is fine, but we might have a problem in terms of our actual, what do you call it, shader programs. Okay, let's look up the geometry. We have a nicely shaped triangle, so that's not the problem. The geometry does get created correctly during our draw call. So what's going on? Maybe our winding order is wrong. Maybe our culling is wrong. Maybe our shader program is wrong some way. So we need to debug this, because we can see that our geometry gets created correctly. Our data gets uploaded correctly. Everything should be fine, but we're not seeing anything on the screen. So let's try doing no